Okay, it is a review class or recap class. That
Yeah.
hello, is there any problem? Is there any problem?
No, sir.
Okay, so just I am recapping the topics. First of all, we have to learn about the ray diagram and beam of light. What is beam of light? First of all, let us discuss about that. So, a beam of light travels in a straight line, and that's why this branch of optics is called ray optics, or sometimes geometrical optics, because the straight light travel in a straight line, and this straight line path of the light is called ray. And we can see this when we look beam of light, such as searchlight, torch. You switch on the torch, or laser beam, a car headlight, and torches. All this source of light produce a beam of light which travels in a straight and called ray of light or beam of light. The only difference is that a bundle of ray of light is called beam of light. So ray is a small intensities. Ray is a small intensities. On the other hand, beam is a bundle of large number of ray together is called beam of light. Now, this is why we cannot see around corners and why shadow are formed. Now, ray boxes. Let us check out. We can investigate light by using a ray boxes. In a darkened room, a ray boxes produced a narrow beam of light called a ray of light. That means very small part of beam of light is called a ray of light, which makes it easier to study effects such as reflection and refraction. So, in order to have accuracy in a study of reflection and refraction, we just use ray of light, not beam of light. So, you see here, uh, ray boxes produce very small part of beam of light. Now, ray diagram. What is ray diagram? Let us check out. When we draw a diagram of an experiment using a ray box, we represent the beam of light using a straight line with an arrow placed on the beam showing the direction of light traveling. Now, when we draw a ray diagram, we must put an arrow, we must place an arrow over the end of the line or anywhere on the line indicating the direction of the propagation of the light. Use a sharp pencil and draw clearly and accurately the ray of light. Now, what is normal? What is normal? When we draw a ray diagram and a ray of light hits the surface of object, we add a line to the diagram called the normal. Normal is drawn always perpendicular to the surface of the ray diagram, that is reflecting surface. Normal is always drawn perpendicular to the surface which reflects the light. So normal is drawn in as we can measure the angle between the ray and the normal. Normal is a hypothetical line, not a real line. It is hypothetically drawn there. It is a reference line with respect to which the inclination of incident rays and reflected ray can be measured, and hence law of reflection can be explained. So this is the normal, this is the reflecting surface, and this is the incident ray, that is incoming rays towards the reflecting surface is called incident ray, and angle, and this line is perpendicular to the reflecting surface, so angle made by the incident ray with this normal is called angle of incidence. You see here, you don't measure, always remember, don't measure angle of incidence with the reflecting surface. If sometimes you are being asked that angle made by the incident ray with the reflecting surface is 30-degree, then what is the angle of incidence? Then a student may get confused and they will say that angle of incidence is 30-degree itself. But it would be wrong, because you know well that angle of incidence is defined as the angle that incident ray made with the normal. So if it makes an angle 30-degree with the surface, then 90-degree minus 30-degree equal to 60-degree, angle of incidence will be 60-degree. Okay. Now come to the point. Now optical phenomenon is a reflection. What is reflection? Try to understand. We see the things around us which are luminous and non-luminous. Luminous objects are those which gives out light and hence act as a source of light, and can also be called light source. So how does light from the light bulb and other light source reach to our eyes? This happens because when light comes out of the bulb, it travels in the space in a straight line and is called beam of light. If we consider only one part of this beam, that is called that is called that is called ray of light. So light travel in a straight line directly into our eyes and then produce a sensation of vision onto the retina, and in turn retina converts the incident light into electrical signal and is then transmitted to the brain through optical nerves, and then we able to see, and then vision is completed. So if light enters into our eyes and retina is unable to convert it into electrical signal, then vision will not be completed. So you might have seen some person, although having a very beautiful eye, but he or she is not able to see. Only reason could be that the internal part of eye, his or her eye, is not developed so that it can convert light rays into electrical signal that can be transmitted to the brain for the analyzing. Seeing non-luminous object. So luminous object is visible from distant place. Now, in order to see non-luminous object, like this book is not emitting light on its own. So one need other source of light to see it. That this book is lying on the table in a room at night, and you enter into the room, but you won't be able to see this book. Why? Because in order to complete process of vision, there must be a source of light that could illuminate the book, and then book will reflect that ray of light to the eyes, and then vision will be completed. That's why at night one has to light up the candle or any other source of light to see the things in the room. So light from the light source strikes the book, and some of the light is reflected into your eyes, and this reflected light converted into electrical signal and then transmitted to your brain, and then you realize that that object is whatever. Now, so far we have learned about there are two types of object surrounding us: luminous object and non-luminous object. Stars and sun are luminous object. On the other hand, planets and moon and asteroids all are non-luminous object. Transparent and opaque. In context with the light, we can even discuss about there are two types of substances. One allows the light to pass through it called transparent, other does not allow to pass through it called opaque, and in between the two characters there is also a type of substance which partially allow the light to pass through it called translucent. So transparent materials such as glass let nearly all the light that falls on them pass through, and very little light is reflected or absorbed by the materials. On the other hand, materials such as wood do not let any of the light that falls on them pass through it, and all the light is either reflected or absorbed by the wood, so called opaque. And translucent materials such as frosted glass let some of light that falls on them pass through it, and the rest of light is reflected or absorbed by the material of the glass. So such material is used in the window pane in a house. And now let us check out shiny surface. Surfaces reflect a lot more of the light that falls on them than matte surface. That means rough surface. So few surface reflect light much more, and that surface is called shiny surface. They often look brighter than the surrounding object as more of the light falling on them is reflected into our eyes. So they appears brighter in comparison to other object, and you can often also see reflections of other object on their surfaces. And such shiny surface object is mirror. Mirror are a piece of glass with coating of silver on one side, and hence other side act as reflecting surface. The silver reflects the light passing through it through the glass, and if the surface of the silver is flat, we are able to see reflected image clearly because the light from them is reflected by the mirror into our eyes. So we have seen that any object with shiny surface can be used as a mirror. Even if you purchase a new steel utensil for your kitchen purpose, and if you see yourself keeping your face in front of the surface of utensils, you will be able to see your image, but not as much clear as you see in mirror, because the surface of utensils are not so shiny, so smooth to reflect maximum light coming onto its surface. That's why we see fainted image. On the other hand, if amount of light to be reflected is increased to extremum by a shiny surface, then that shiny surface acts as a mirror. So now let us talk about the mirror. What is mirror and types of mirror? When we draw a ray diagram, we represent a mirror by drawing a line with a dashes on the silver. You see, this sign indicate that this mirror is silvered from this side. So reflecting surface is this side. Now, and silvered portion is non-shiny, because after layer of the silver, a protecting layer of paint is provided there to protect the layer of silver. Most mirrors are flat and these are called plane mirrors. All of you must having plane mirror in your house, or even this is called looking mirror, and they give non-distorted lifelike image. So when you look into the plane mirror, you get your image non-distorted and lifelike, that is live image of your own. On the other hand, if you see on the curved surface, then it will give the image which could be different from the actual object. So here, this is a plane mirror. Now, what about if the reflecting surface is made curved? Then that mirror is called a curved mirror or a spherical mirror. So you see here, instead of this like a straight line, here is curved line is drawn and is silvered from that outside. So this is called concave mirror. So some mirrors are curved and these give distorted images. This is the difference between the plane mirror and. So curved mirror gives the distorted images. That means image will be different from that of the actual object. And even size of image could be different from that of the actual object. But in case of plane mirror, we always get the size of image as much as that of the object. Only there is a lateral inversion, that is left side of the object appears right in the image. Now if mirror curves inwards, then it is called concave mirror. This mirror curves inwards. You see here, its reflecting surface is inwards. Its center could be somewhere here. So this is called concave mirror. But if it curves outwards, it is called convex mirror, and you see here it is silvered from inside and its center could be somewhere here, but its reflecting surface is outside. So this is called convex mirror. Now let us check हाँ जी, अभी देखो क्लास ले रहे हैं. Plane mirror and reflection from plane mirror, and you will come to know the law of reflection. You see here, this is incident ray coming towards the mirror. This is a plane mirror. You see, this is the glass, and this beneath the glass there is a dash line, dashes line, this indicates silver. So that means this glass is silver from bottom side, so its reflecting surface is at the top of the glass. When a ray of light coming like this, then after reflection, this light will go like this. This ray is called reflected ray, and this is called incident ray. Incoming ray is called incident ray, and this is called. Now, the inclination of incoming rays and outgoing rays or reflected ray is to be measured. For that one, we have to draw a reference line onto the plane of the reflecting surface. This reference line must be perpendicular to the reflecting surface and is called normal. So this red line is normal. So this incident ray makes an angle I with respect to this normal. So this I is called angle of incidence. Similarly, this reflected ray makes an angle of a reflection R with respect to this line normal is called angle of reflection. Now, in order to understand law of reflection, there are two laws of reflection. First one says that all the incident ray, normals and reflected rays lie in the same plane. This is first law. And second law says that angle of incidence is always equal to angle of reflection, that is angle I equal to angle R. This is second law of reflection. So this is called the law of reflection and is true for all and any type of wave, whether it is sound wave, whether it is any type of heat wave, and being reflected from the surface. On the basis of reflection from the plane mirror, we can develop a device which is called periscope. A periscope consists of two plane mirror inclined at 45 degree at end of the hollow pipe. You see here, this is a plane mirror and this is also a plane mirror, and this is a hollow pipe, opaque boundary. This is opaque boundary, and in this hollow pipe at this corner two mirrors. One is this one at 45 degree, another is this one at 45 degree with respect to this one, and with respect to this one 45 degree. Okay. Now what happens when a ray of light from this side comes and strike this surface? It will bend through an angle of 90 degree and follow this path, and again here it will bend through an angle of 90 degree and follow this path. It means it is clear that a person who put his or her eye here will be able to see the object which is above the walls or opaque object or outside the opaque object. In submarine, one can see the outside surroundings by being submerged in water with the help of this device. So by positioning two plane mirror at 45 degree to each other at either end of the tube, we can make a periscope, and periscopes are used in submarine to see what is on the surface of the water from underwater. So one can see from underwater. Even in a war tank, operator will be inside and will not be visible to outside people, but the operator can see the outside people with the help of this periscope. Now, with the help now with reflection, with the help of plane mirror, there is a phenomenon that is called lateral inversion. That means if objects right, if object is in front of a plane mirror, then image of same object will appears to be inverted right, and this is called lateral inversion, sidewise inversion. When you look at some writing in a mirror, you will notice that it appears backward. We can work out what is happening by drawing a ray diagram. Say this is A alphabet. You will see that this A will be laterally inverted. That means its right will inverted to left. So you see here, this is the object and here it is image. So it get inverted. You see, this is the incident ray coming from the object like this and reflected into the eye. So our eye will assume that light is coming from this side. So this C portion of A, this is CAT, cat, you see here word is cat. So here cat will appear this side. If you see here, this is left side and T is right side. Here C will appear right side and T will appear left side. So that literally inverted. Now again, a ray of light coming from T, that is at the end of the word cat. Then he or she will able to see the T at this side, indicating that in actual sense C is at the leftmost, but in image C becomes rightmost and T becomes leftmost. So just to get involved. Similarly, you see here L, everything will remain same, but lateral inversion will take place here for the P also. So light rays swap over when they are reflected. This causes the image to appear laterally inverted. That means backwards when compared to the original object. Now come to the point, virtual image. What is virtual image? When you look at the mirror, you see a virtual image that appears to be behind the mirror. This is not actual image, it is virtual image, because actually the ray coming from the object is not passing behind the mirror, but it virtually appears to be coming from this point. That's why this is virtual image. The image appears to be the same size as that of the original object and the same distance behind the mirror as the object is from the mirror. This is the characteristics of the plane mirror. So this distance from the distance of object from the mirror is called object distance, and distance of image from the mirror is called image distance. Image distance is denoted by V and object distance is denoted by U. So you can say this is the object. So distance from here to here is called U, and from here to here is called V. And you will see that V equal to U in case of plane mirror 1. Now, so we have discussed all about the plane mirror. Now let us check out hello, is a screen visible to you or not?
Yes, sir. Yes, sir.
What you are seeing on the screen? Types of mirror. Okay? Types of mirror, and then you will see a reflection from the curved mirror. So let us go. I have already discussed types of mirrors. Now virtual image has already been discussed. Now come to the point. Concave mirror. Mirror reflects rays of light to a focal point F. All the incident ray parallel to principal axis reflected back to a focal point in case of concave mirror. Concave mirror, therefore concave mirrors are called converging mirror because it converts all the parallel incident rays to focus after reflex. That's why in a solar cooker, concave mirror is used for focusing all the incident rays to a focus where food gradient is placed. So food gradient get much more heat energy concentrated form in the form of concentrated rays, and hence food gradient receives that much heat, and automatically it is helpful in cooking. As the ray of light converts to focus, if a light rays is placed at the focus, if light source is placed at the focus, reverse will be effect there. That is, right now light source is at infinity, so light is coming from infinity, so parallel, and after reflection it becomes get converged to focus. What will happen if light source is placed at focus itself? Then light ray will follow this path, and after reflection becomes parallel. I have already discussed all this. So if a light source is placed at the focus, they produce a beam of light parallel to the principal axis, and the distance between the mirror and the focal point is called focal length, which is denoted by F. You see, again, distance between the focal point and the pole of the mirror is called focal point. Here is pole at the central point of the mirror, and it is denoted by small f. The more curved the mirror is, the closer is the focus is to the length, to the mean. Here lens word must not be used because right now I am discussing about the mirror. Now focal length of the concave mirrors. Find focal length of a concave mirror. You see here is the object and here is the mirror. This is the concave mirror and this is the object, distant object. This is the rough method to calculate focus of concave mirror. If you are inside the room or in your house taking a concave mirror, hello, yes, okay, just yes. Try to understand. So we take a distant object as assuming that object is at infinity. So in comparison to size of this mirror, distance of this object from this mirror is infinitely long. So we can say that this object is at infinity. And therefore, all the rays after reflection will converge at a point. That point will be called focus. So with the help of a meter stick, we can measure the converging point and the mirror as the focal length. So this is the focal length. Now, this is the rough idea to calculate focal length of a mirror, concave mirror. Now, what is usage of concave mirrors? Nowadays, you might have seen the DTH disc fitted at the roof of your house. If you see the shape of the disc, it is a little bit concave like because it is deeper at the center, and the video signal coming from the broadcasting station or channel via satellite, as satellite is much more away from the disk, so satellite is assumed to be situated at infinity. So ray of electromagnetic wave coming from satellite to this disk is at infinity, and you see this is the receiver that receives the signal. All the incident electromagnetic wave or audio signals strike this surface, and after reflection converts onto the focus. So this receiver is situated at the focus. If you displace this receiver from this position, your TV would not give the clear picture. So when your receiver receives all the reflected electromagnetic signals, then picture will be clear. And now try to understand. Concave mirror are used in allowing them to be more powerful for their sizes. So concave reflectors are used to focus the signals from distant satellite. Now this is the convex mirror. You see it is silvered from backside. So convex mirror reflects rays of light away from the focal point. This is the focal point, so it reflects away from the focal point. That's why convex mirror is called diverging mirror. Concave mirror is called converging mirror, and it is called diverging mirror. So convex mirror are diverging mirrors because all the parallel ray coming from infinity towards the mirror get diverged out after reflection and appears to be diverged out from the focus. So it is called diverging mirror. Parallel rays reflected, so they appear to have come from a spot called the focus. What is use of convex mirror? This is convex mirror. You see as a side mirror. Convex mirror is provided in the vehicles as a rear view, and this is also convex mirror. So convex mirror are often used to see around the corner because convex mirror gives higher or larger field of view because of diverging nature and forms a smaller image. Here is here in a VG corridor, convex mirror has been used to see the corners. Now, the rear view mirror is used in a vehicles, in a car, is a convex mirror to widen the field of view. And after that, let us summarize the activities that we have completed, and here is some glossaries. Concave mirror, a mirror that curves in at the center, and a convex mirror, a mirror that curves out at the center. An incident ray, the light ray that strikes the reflecting surface is called incident ray. And what is law of reflection? Law of reflection: when a light is reflected, the angle of incident equals the angle of reflection. Now, lateral inversion. What is lateral inversion? Lateral inversion is basically reversal of an image in a mirror, which means that left hand side of object appears on the right hand and right hand appears on the left hand. This is called lateral inversion. What is normal? A line on the ray diagram drawn perpendicular to the reflecting surface is called normal. Now, what is plane mirror? A mirror with a flat surface or plane surface is called plane mirror. A reflected ray, the light ray bounces back from the surface after incident is called reflected ray. And ray diagram, what is ray diagram? A diagram that shows what happens to the light rays during the process such as reflection is called ray diagram. This is the all about